Web Service APIs in .NET 7 with Shawn Wildermuth.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, to deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm empowering software delivery for business-critical software projects, and they focus on project delivery and team empowerment using the ClearMeasure Way methodology for effective software projects. A quick announcement, my architect forums are going strong and signups for the next session are up. And so if you lead a software team or a lead engineer or architect or even development manager, and if you're looking to collaborate with some of your peers out there in the industry, then go ahead and sign up at the link in the show notes. And also for those of you looking for Programming with Palermo, my video podcast, just go ahead and search in any of the directories and you'll be able to find it. A returning guest on the show today is Shawn Wildermuth. Shawn has been tinkering with computers and software since he got a VIC-20 back in the early 80s, and he's been a Microsoft MVP, Pluralsight Author, and filmmaker. And you can reach him at his blog at wildermuth.com. That's WILDERMUTH.com. And he makes films at twainfilms.com, TWAIN films.com. So, Shawn, welcome back to the show. How are you, sir?
I'm great. I'm really happy to be back here. I remember us talking last time about APIs, and I've dived even further into that stuff. So I'm excited to talk about it.
Fantastic. And you've done some recent speaking. Well, you've been speaking on that topic for a long time, haven't you?
Yeah, it feels like, I created a course for Pluralsight back in the day, a .NET Core beta. Didn't even have a version 1 quite yet. So it's been an interesting evolution through this whole space where it all looked very much like the .NET framework, and now things have moved a little. So I'm excited about the direction it's taking.
Yeah. Well, I'd like to ask all of the guests, some of the high points in the career that kind of lead up to what you're working on now. And I asked you that the last time you were on the show, but I want to ask kind of a different question because you fell in love with computers in the 80s, and then you've been in programming for multiple decades. There's some subset of the industry that's the past the double decade club, and I fell in love with programming in the mid 90s. But my question to you is, what is it? And because there's a lot of young developers that are listening here, and our industry's expanded in a big fashion. What is it about programming that has actually kept you engaged and kept you interested, where you stuck with it instead of like, maybe I'll move into management or maybe I'll do something else? I mean, what is it? Because you're one of those people where you still have the love of coding.
I do. It's been an interesting ride. I started coding again in the early 80s, home computer and all of that. And for about 10 years, up until I was maybe 25, I didn't want to be a programmer because in my head, I had this stereotype of like, I look like the comic book guy in some ways. And I wanted to break that like stereotype. Like I didn't want to, it was much cooler to say I was an unemployed musician at a party than to say I was a computer programmer, right? It was just that, but it was inevitable because I love the puzzle. The puzzle feeds me. If you've ever seen an episode of the show House, the show House has a very predictable format, and there's the thing that happens, and then there's an epiphany moment in every episode where they're like, oh, that's what he has. Like he has this, and that's what happens to me in programming. That's exactly what happens to me in programming. And that I'm like, struggle. This is, I go through this magic curve of starting to work with a new technology and my first sort of curve up is, oh, they're stupid. They're doing this the wrong way.
Mm-hmm.
And then I get to, oh no, I'm stupid because I can't understand it. And then I sort of, as soon as I crest that hill, it there's a sort of a huge dopamine hit of like, oh, okay.
Yeah.
And that's what's always kept me in there is I'm super curious. Watching people use the things I've built in the past has always been, really exciting.
Mm-hmm.
Just to sit down with users and get that feedback that I'm actually making a difference, not just cutting jobs or calculating royalties or
Mm-hmm.
for me there's two parts. There's the puzzle that feeds me sort of day to day, but there's the are we doing something interesting over here? And that doesn't mean like everything has to be for the greater good, but are we doing something more than just writing one more forms over data application, right?
Mm-hmm.
Are we improving the business? Are we making it easier for customers to use it? Whatever it is,
Yeah.
that part, you know because usually a business is part of the puzzle for me.
Mm-hmm.
When I was in consulting, I loved it because the first like month, I would get to understand how these businesses worked, and it was just fascinating. Like, there's a company that does that,
Yeah.
really, like that very specific thing.
Yeah.
That's awesome.
Right. Right. Yeah, it is interesting, and for anybody who hasn't been in consulting, when you work in one company's IT department and you're a couple levels down and you work on one system, that's one perspective. But like there's this one company in my history that's a railroad company that stands out, and that's the one time where I walk into this operation at a rail yard, and in are coming trains, and massive amounts of material are being taken off these trains, and out the other end of the factory is the same material packaged up in a smaller package that actually has a price tag on it that somebody can buy and actually lift up with their hands. I'm like, yeah,
Yeah,
somebody has to do that.
yeah. My favorite one of these is I was working for a company in Joplin, Missouri, and what they did was they delivered trucks.
Hmm.
So Peterbilt and big tractor trailers, when they were manufactured, they have to deliver the tractor trailer somewhere.
Yeah.
And if you've some people have seen this, and if you haven't, you will now see it because I've mentioned it. But you'll see a tractor trailer and three tractor trailers on the
Yes.
back of it, sort of.
With like a
And
wooden
they,
chalk as a hitch.
yeah, yeah, it's amazing because when they finish all four deliveries, they have some driver in the middle of nowhere
Yeah.
that needs to get home,
Hmm.
right?
That's true.
And I was just fascinated with like, oh, what happens to all his giant tools and all the like? It's not just getting him to an airport; it's taking 200 or 300 pounds of equipment and trying to get it back
Hmm.
to one of their depots. Like, it's just that
Yeah.
was this, that's all they did was this little really interesting thing that I'd never noticed before. And as soon as I started working for them, every trip I see like three or four of them because it just didn't occur to me.
Yeah. And for anybody entrepreneurial out there, there's an unlimited number of business ideas. You just, yeah. Well, I want to ask you about APIs because
Hmm.
um, over, over the last 20 years, how to get program A talking to program B has had so many permutations. And now the word, what was it? There was a period of time when everybody used the term web service, but now everyone uses the term API. But of course, that could mean anything, sort of. So, how should how should developers be thinking about just the concept of an API? What are the categories that they should be aware of?
What I think you're asking, and correct me if I'm wrong, is that we have a number of different ways of having different systems talk to
Yeah.
systems. We like to call them APIs, and there are different needs. Like I talk about this sort of history of like remote procedure call messages and queues were
Mm-hmm.
all invented in the early 70s. Like, none of it is all that new.
Yeah.
Um, and so we got into this place where we're doing a ton of REST, right? REST was a solution to a much harder problem of having to open ports and firewalls and
Yeah.
all this other stuff that, decom, com, all those
And maybe a
uh,
revolt against SOAP
dark
somewhat?
days. Say again?
A revolt against SOAP as well?
Oh, yeah, yeah, yeah. SOAP was a great idea until you learned how it worked. Yeah, SOAP is an interesting sort of blip on that screen of history of APIs.
Yeah.
And so we sort of settled into this place with REST, and REST still, represents a lot of it. And when I say REST, it's an API that goes over a normal web port. So that means it's a call that's using port 80, port 443, or a special port that you've already opened up on your firewall. And that simplified needing to do that in a big way. But the core idea around REST is that the URI is going to be descriptive of how you interact with it.
Mm-hmm.
And that doesn't work for every kind of API. It's incredibly valuable to use REST for CRUD, for database, forms over data sort of
Mm-hmm.
applications, because it actually maps really well. You can think about, if you think about CRUD, create, read, update, and delete,
Mm-hmm.
REST is post, get, put, and delete, right?
Mm-hmm.
It maps in a really well worn place of one-to-one. But it doesn't do some things well, and that's why alternatives have sort of come up. And so things like GraphQL has come out. You see gRPC
Mm-hmm.
and a bunch of others that are sort of sitting there. APIs as a service, management of APIs and things like Azure and AWS. And what's interesting is we used to fight about what the right way to do this stuff was, right? REST versus SOAP, and
Mm-hmm.
then XML versus JSON, and all of this. And I've come to this sort of polyglot idea about services. I don't know whether we talked about this last time, but that there are different technologies that work better. And I think for large, wide applications, you may be using one, two, three, four, a dozen of these, right?
Mm-hmm.
You may be mixing and matching because we know that REST does what REST does well. We know that what GraphQL GraphQL does well. GraphQL, in my opinion, at least, is great for like reporting systems because it gives you a sort of a flexible schema to go ahead and query against, to look at and understand the data in a way that the client can define instead of having it as this fixed endpoint that you would do in REST. Um, and gRPC is really good when you need that efficiency. IoT and inside of a system are places where the efficiency can be helped because
Mm-hmm.
it's very discrete. It's binary based. It's contract based, and so it's not really tightly coupled in the way we used to talk about it. But knowing what is on both ends of the pipe make it easier to be efficient.
Yeah.
Whereas REST is a little more loose, even though we can define schemas and all that.
Well, if you need
And
to be
so,
compatible, then you kind of need text. If you don't need to be compatible with everybody else and it's just you on
yeah,
both sides of the wire, you can kind of dictate it.
yeah, absolutely, absolutely, and you get benefits because serializing, deserializing, when you know exactly what that binary format is,
Mm-hmm.
can be really efficient. So, IoT is one of the places where that is huge because you have limited
Yeah.
resources as far as CPU and memory, and so that efficiency really pays off there.
And
You
battery
could certainly,
life. A lot of those
yeah,
devices are
yeah,
running on a little battery. And
yeah,
how often are you going to use up the battery? How long is it going to last?
yeah. How long? How often do you need to have a human being go out and change the batteries? Like
Yeah.
that's the huge cost. Absolutely. And so back in the day, like when I was doing SOAP, um, I very much created APIs as they were needed.
Mm-hmm.
Like a customer would come or the web developers would come and I need to do X, Y, or Z. Can you create one? And I would create one that worked and everything was fine. But maintaining those APIs, some of those APIs still exist 20 years later.
Yeah.
I realized the fallacy of just like one-offing it.
Mm-hmm.
And I've been on this binge of we need to design our APIs before we think about the technology. Like we
Mm.
need to figure out what we need and make it flexible enough that we can mature it over time without getting bloat. The canonical case is you go into an organization and they have some REST API, and that REST API has 400 endpoints because every time they
Yeah.
needed something, they just added it to the end of the file.
Right.
And that not only bloats it, makes it harder to maintain it, but it also makes it harder to understand what you have. Once it gets that big, what tends to happen is someone rewrites an API because they couldn't find the API that actually served that.
Mm.
And so it just becomes a muddled mess. And so one of the things in .NET 7 and 8 that I really like is they've finally adopted this idea of REST or HTTP files, which is sort of a format where you can write HTTP requests and sort of test them at that place.
Mm-hmm.
And so when I design an API, the first thing I do, the first outlet of the design stuff I've done is one of those files so that I can start to go, okay, as I walk down this, I know what that interface is. Now I'm going to write, I'm going to be writing APIs to fulfill essentially the contract that we've done in the design. Doesn't mean it can't change, but that way that you have sort of the coverage of all the pieces and that you've covered the use cases that you've looked at in the design phase.
Mm-hmm.
Because APIs are such a thing that I don't think it matters how you implement them in some sense. Because the person on the other side of the wire doesn't care if it's .NET or Java or Python or whatever it is, right? Ultimately, it's you would take time to design the UX for the screen, but not for the API. Like that is the user experience for the developer is the design of the API.
Well,
I think it needs.
I like the words involved because UI, well, that's just short for user interface. And API is not a word, it's an acronym, application programming interface.
Yeah.
And you're right. Some person is using the interface, whether it's setting up their machine to do it automatically or whether it's clicking a button.
Yeah, exactly. And so, that's a bit of my high horse about it, but I think that's a really important part of the whole process. I think you'd be like most development tasks, if you plan on what you're going to do instead of just doing it, you're going to have a better outcome anyway.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
So talk to us about what is the latest for people who've done web services and whatnot. I mean, there's these concepts floating around. Azure has API management. .NET 7 has the HTTP files. What are the newer concept and newer advances that are worth taking a look at?
Well, probably the biggest one for .NET 7 and 8 is this idea of maturing minimal APIs, which were introduced in .NET 6.
Okay.
And if you want to think about what minimal APIs are, I suspect that a lot of the developers that listen to this are using Model View Controller, right?
Mm-hmm.
You have APIs that are developed in a controller, and then those are being called by convention. And those are still a great way to design, to develop APIs. Like it's tried and true. It's great. Like I often tell people, because Microsoft introduced it doesn't mean you need to move to it. But if you start to look at the model, you may be interested in moving to it for other reasons. So the concept about minimal APIs is that you can write things as a sort of discrete unit. A call is a discrete unit, effectively a call to define the API and then providing a lambda. So you don't need sort of the class wrapper around it all.
Mm-hmm.
And they've made some efficiencies where that's actually faster than a lot of the plumbing that goes through into a controller. Now, the reality is for almost every project, the speed increase of minimal APIs is going to be swallowed in the actual business stuff they're doing. Like
Mm-hmm.
it's
Yeah.
not going to it's measurable, but it's not significant,
Yeah.
right? It's and so people like, oh, I want to make my APIs faster. I'm going to move and rewrite all my APIs in this. Oh, I think you should be working on improving your indexes for your queries. That's
Yeah.
going to make it a lot
Or
faster, way
or
more faster
call
than
the
rewriting
database
your entire
less.
API.
Yeah.
Yeah.
Totally.
Um, and so that's not a great reason to go to it. But what it does is it opens up this flexibility of how you're organizing APIs in a project, because it really is up to you how you want to do that. Some people are using it where they're building the APIs next to the views or next to the other business logic that they're building, which you can do with controllers, but you can't do it on sort of a one-off. In .NET 7, they've added this idea of groups. So we're starting to get closer to a controller where you can define a group, and then each of the group has a base URI, and then it's very much like having methods of controllers.
Mm-hmm.
And one of the things I really like about at least one pattern of using these. One of the things that I like about the way that at least one architectural style that I've been sort of pushing using minimal APIs is these classes that I'm calling API classes, which on the face of them look very much like a controller. Like
Mm-hmm.
there's a register call that you register all your APIs. And instead of doing them as lambdas, I'm suggesting doing them as static functions because
Okay.
it's essentially what a lambda is, right? It's not part of an object. And why does it matter? Why can't I just create it as lambdas? Why is the static function or method important? It's important because we can now test those APIs without actually running it through any of the web stack,
Okay.
right? It
Yep.
becomes this very discrete unit of, oh, I can call this method, I can give it the inputs it needs, and get the expected output. There's no more having to craft up for unit testing the sort of a fake server
Mm-hmm.
in order to host HTTP calls. Like all of
Yeah.
that is integration testing, and you probably need it in your application. But when you really want to do the unit testing of individual calls, I think it really opens up to be able to do it in the way where you're like, well, there's none of this other stuff is going to be, I'm not going to be testing any of that, right? It is a
Mm-hmm.
unit. It's just one method, does a very discrete thing, and we should be able to test that. And that's one of the benefits I see in sort of doing this. I've actually written a library that uses CodeGen to register all of these so that you can register them very easily. Because one of the other things that is interesting about the way that uh, minimal APIs are working right now is you shouldn't have to ever push them into dependency injection. The stuff they need
Yeah.
needs to be in dependency injection,
Okay.
but because they're static um, uh, methods for the most part, right? No matter how we write them, they're lambda static methods. Um, there is no like you don't need to create the controller. All you're doing is
Mm-hmm.
registering this function to say if it looks like this, please execute this. And so that's one of the ways that it becomes less heavy because there isn't a class to generate every time you need it. There isn't what's the word I'm looking for? Uh, a decision about how you send that in and setting up this large object and um, keeping things alive for the entire controller so that we use a lot of constructor injection, right?
Mm-hmm.
So that we can just inject it once and then when we call. But most API controllers are created, they make one method call and
And
then
then
they
they're
go
done.
away,
Yeah.
right? They're usually scoped. And so this sort of opens that up. The other piece I really like that's new is this thing called endpoint filtering. And
Okay.
it's a way that you can write code that's going to happen before and or after your method call. And you can write them in a really concise way so you can reuse them. Validation is one of these that is just natural. Like, oh, okay, I'm going to add an endpoint filter. You're going to give me a generic argument for the type I need to validate.
Mm-hmm.
And then it should just work,
Yeah.
right? Um, it c- because what we used to do in writing filters, we write filters at this sort of high level and hope that they were going to be part of that chain. Maybe an attribute was going to key it or whatever. And here it ends up just being an extension method, right?
Mm-hmm.
I have my API, validate using, and then put the return type, and you're done. Like it's very elegant, and it's means that more of that code is closer to where we're writing the API. So
Mm-hmm.
reading those extension methods are going to tell you everything that is necessary for that API to be executed.
Yeah.
And so it's almost self-documenting.
Well, that's that's an interesting way to chunk it up, because you're making me think of the logic of what it does, and that's a separate concept from some of the things that you need to do to maybe allow a different program to call in and cause that logic to run. And
Right.
like I'm thinking of caching. If it's just getting some data and that data doesn't change every millisecond, then
Right.
a 1 second cache or 5 or 10 second cache, the callers wouldn't even know the difference. And
Yeah.
so you don't call your downstream databases as much. But the question is, which of those concerns does the actual core logic need to be aware of? Like, for instance, caching. Does the core logic need to be aware that it might be in a caching workflow, or does caching as a concept belong to the interface for the application programming API?
Yeah, it's an interesting question because I think the more you can remove cross-cutting concerns from the actual logic, and this is one of
Mm-hmm.
the reasons why I like being able to execute these in tests outside of all that, because when the call comes in, if you can say, you know, uh, to see if the cache is stale, call the API, or at the other side of it, the call is made. Do we need to cache this data? Oh yeah, we do. Let's go ahead and cache it. But none of that belongs in the actual business logic body, right? We want to confine it there. This
Mm-hmm.
is a little bit of what repositories were trying to solve and taking some of the business logic out of it. And whether they're needed or not is sort of an open question right now.
Mm-hmm.
But I think we're seeing this more. It's almost like the old aspect-oriented programming, right? You're going to write your code, and these other pieces of code that might run before or after to do the important or interesting things,
Mm-hmm.
because it ends up
Yeah.
just being a chain, just like middleware is a chain, right? And so you can have the people that are going to do the hard things of, let's say, validation or caching or whatever it is, write those pieces that then the developers that are doing the business logic can just say, add caching, add, require this,
Mm-hmm.
or document in this way. And I find that very satisfying. Though there are cases, I still think there are cases where you start with minimal APIs and you might end up in controllers when it becomes too overwhelming.
Mm-hmm.
So there, like a lot of these things, there's always compromises on both sides. Because ultimately, some organizations benefit from saying, oh, this is the way we're going to organize, instead of saying, how should we organize
Mm-hmm.
our APIs, right? That becomes a thing where if you're in an organization, you're already using controllers, and having that sort of, well, Microsoft says this works, leave it be as far as I'm concerned.
Yeah.
Like the place where minimal APIs were, I think were meant to solve is sort of two things. One, so you could write a node-like application in C#, frankly,
Mm.
like the simplicity of top-level statements, and then being able to just call gets, like all of that is very attractive. Um, And there are two cases where I think they were shooting for. One is prototyping. Like, you start a greenfield application, you can write, just a program.cs and get your developers working on the actual work, right?
Mm-hmm.
It doesn't even have to be porting in real money. You
Yeah.
just defined an API and you can just prototype them really quickly without a lot of the middleware that you have to make controllers work.
Yeah.
The other case is microservices. So, I've created a microservices system where everything only has like 2 or 3 calls in it. And then you can do that very discreetly and not have to build up again all this architecture for these things like microservices. If that's something that your company is going to benefit from, minimal APIs are a natural fit. But when you start to get into what most people are doing, enterprise level development, it's a little more abstract.
Mm-hmm.
I'm not sure that minimal APIs are the way to do it, right? It's another one of those things where Microsoft is saying, you know what, model view controllers are awesome, but there are cases where they're too heavy or they're too constrained.
Too hard to get started with. Or there's too many concepts. More concepts than necessary if you just need one or two.
Yeah, absolutely.
Well, you had mentioned factoring off the logic into a simpler fashion where you can just more use unit testing. But what is your favorite method of complete testing, full system testing when it comes to everything that you've put together? You have your, the guts of it, the logic of what it actually does, but then you have the middleware part. Maybe you've added on a little bit of caching. Maybe you've added on some filtering or rate limiting or whatever it happens to be. There's other stuff involved. What is your favorite method for testing the complete set of web service APIs?
Well,
in an automated fashion.
I'm not a huge fan of spending a lot of energy writing automated tests. For large organizations really benefit, but most of the companies I work with are smaller and are resource constrained. And so some of it is having a QA department that goes through and like literally clicks and sees whether smoke builds works, things like that.
Mm-hmm.
What I do recommend are integration tests. So these are tests that are run at the same time that unit tests are, but they include sort of top to bottom. You're creating a web server, you're calling that web server with, let's say, an in-memory or an actual database, and flowing through all those different layers. Because to me, integration tests and unit tests are for different things.
Mm-hmm.
Unit tests are, if this breaks in 2 years, I want to know it's breaking before we get this to a customer.
Yeah.
Integration tests are, does this work now?
Mm-hmm.
Because as things change, sure, the 2 years or the 10 years down the road, unit tests and integration tests matter. But I think the integration tests are much more, I have 20 people working on this. We have to bring all their work together to make sure it works together, right? Yeah. All the unit test passing doesn't tell that story.
Right.
And if you're in a large enough organization doing automated testing there's so many tools out there to do it, I think is useful. It's just not something that I've seen gain a huge benefit.
Mm-hmm.
If you're getting into perf testing, some of the automated stuff like Westwind has a great testing library that he's released. I think it's free. He's going to yell at me later when it costs money, but I don't remember. But Westwind, where you can automate this, like run it, how many, I'm going to run 1 million transactions. Let's see how well it performs and all that. And I think that can be useful, as you're refactoring or developing a system to make sure. But that belies one of the things that I see a lot, and that is people over optimizing code, right? There's a cost to building code and there's a cost to optimizing code, and premature optimization lags projects way behind because sometimes you don't need. And I talk to organizations who are like, yeah, I have 30 users in my company that use it. And I'm like, well, you're never going to run into it doesn't need to have 1 million transactions a second.
Those are
when
always
you have
easy. 30 people. Yeah.
Yeah. But because I think young developers are told that they have to, meet these metrics in order to be considered like it's a good system, whatever we're, you
Yeah.
know, in quotes, whatever we mean by a good system. I think they can get lost in if my system isn't the most efficient it could be, then someone's going to find out that I don't know what I'm talking about.
Yeah.
Like it becomes this sort of more emotional thing of like, this needs to be
Right.
perfect, and in once upon a time that was absolutely true.
Uh,
But in the world we live in now, fortunately or unfortunately, we can throw hardware at it. Scaling out in Azure or AWS is, literally a click of the button. It isn't
mhm.
something you have to architecturally set up your whole system with, and usually users, the difference between 1 millisecond and 100 milliseconds is not anything they're ever going to notice,
Right.
right?
That also makes me think about uh, other kind of level of complexity domains, and concrete is the same way. And I'm not a construction guy, but if I needed to pour some concrete for a walkway up to my steps or whatnot, you
Mm,
know what? I could figure out how to do that, and I could pour a little sidewalk for myself and be just fine. I don't need to hire, a big concrete truck and a crew to come in and, pour a little sidewalk, and because I'm going to walk on it, a bicycle, a wheelbarrow, a trash can, that's basically as
yeah,
good in use. And even, but a driveway, there's a certain level if you just drive in the car. Now, if you're going to drive a 50,000 pound RV bus on your driveway well, now it's a different driveway. So
a
it's
whole
that
different
type
driveway.
of versus, an interstate highway with tractor
Yeah, yeah.
trailers and whatnot. So the same way in computing, like you mentioned, there's some type of code, the environment that it's going to run in, almost anything will do the job and you're not going to have an issue. It's all about understanding where the levels of stress tick up to the next level, and making sure you account for that, right?
I think so, but also that refactoring is cheaper than it's ever been.
Yeah.
And so if you need to fix those bottlenecks, it's not going to be that difficult,
Yeah.
right? Because writing code, back in the day when I was doing C++ and C, it was every line of code was expensive, and the idea of going in and fixing it later, because of the complexity of the languages at that point, meant we had to get it right. Like
Mm-hmm.
we had to get it right first, because patching it would be difficult. Like it's
Yeah.
not, oh, I'm just gonna have my CI server put it up on a new instance of Azure.
That's right.
Like that's the idea of, we used to ship computers pre-built with the software that these doctors' offices needed.
Mm-hmm.
Fixing that is hard.
Yeah.
Like, do you ship them another machine with the fix? Do you have like
Yeah.
it's so much easier in many ways than it ever has been. And so um just knowing that, like knowing that the that your job as a developer isn't the bits. Your job as a developer is the business logic.
Yeah.
Like in almost every case, um, and what's interesting is I'm less interested in how the CPU works than I am with how the business works.
Mm.
Like the thing that a sort of epiphany moment isn't just I'm learning this new technology. It's also I'm able to build a system that's able to solve a business problem.
Mm-hmm.
Because ultimately, if you pay me, the company has to make money on what I'm doing so they can continue to pay me. Like
Mm-hmm.
that's
Yeah.
that's a sort of virtuous cycle, and I can get behind that really well. Does make it harder when there are companies hiring that don't believe in what they do, and so I don't want to be part of them. But that's a whole nother
Yeah.
discussion,
Well, you mentioned running the code, and I want to kind of close on this, and ask you. Well, I'll ask you what the best solution is, but of course, with the it depends more of what is the most common way to run APIs, and how would you recommend developers make that decision of where and how to run these web service APIs that they built?
Well, that's interesting because I think we're in a cloud world.
Mm-hmm.
Whether you think that you need to run your own data center or not, I think even those data centers are run like little clouds. And so having a way to deploy these systems in a somewhere in a cloud, whether that's yours or not, I think is the important part. Like most of my clients work with Azure,
Mm-hmm.
and because they're smaller companies for the most part, we don't get into Kubernetes or any of those because they're not building those kinds of applications.
Right.
And so very much a lot of the applications I work with are static websites in Azure for the front ends, and then API servers, which we'll need fewer of than the static websites often, in app services, because it's just, here's a code. And in some cases, when we need to be very specific, we might use a VM. But this idea of how we're deploying code now, I think, is really interesting, because all we've done is abstract out the operating system,
Yeah.
right? We've come to the point where I don't want to be responsible for patching a VM or
Right.
patching or running it on physical hardware.
Yep.
Like, that's just not a concern I want to care about. And so sometimes it will be creating containers that are hosted in app services.
Mm-hmm.
Because I can scale those out to the kind of sizes that my kind of customer needs. But for larger customers, looking at things like microservices or hosting things like Kubernetes to be able to manage all these disparate systems is certainly a way to go. That what's interesting about microservices to me is that one, I don't think most companies actually need them. I think
Mm-hmm.
we've done a disservice to developers by saying Netflix does it this way, therefore every application needs to do it this way, right?
And Netflix itself has walked it back.
Yeah.
Because they went too far.
Yeah, exactly. Because all you're doing is you're trading complexity of code for complexity of infrastructure.
Mm-hmm.
And I got to tell you, I'm more comfortable with the complexity of code than I am in the infrastructure space. Like, there's a reason I'm not an IT guy, that I'm a developer guy, right? There's things that I don't want to care about. And, the OS is just one of those things. I feel like, just like memory management, and just like, storage, having SQL versus flat files, like, we've been abstracting complexity out the whole way, and this is just another level.
Yeah. Awesome. Well, hey, I could keep on asking questions for several more hours, but for time, I appreciate you coming on the show and sharing with us the latest thoughts in .NET APIs. Thank you so much.
I love the sound of my own voice, so I'm happy to do it.
Very good. Very good. Very good. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.